अब चलते हैं, let us solve another numerical problem on pulley systems. Hope by now you have watched my previous two videos on pulley systems and how to do it quickly in less than 1 minute for your NEET 2021 examination if it is asked. Now I have also explained why the tension is always away. Let me explain it once more here and then come back to the problem, solve it with equations and then tell you the shortcut for that. Now here is a bundle of rope. I take a piece of it. So can I hold it straight like this, horizontal? No. So by holding a piece of this rope horizontal, if at all I can I push the gentleman towards the right, towards this side? No. But if I tie the rope to him, I can pull him to this side. I can pull him to this side. Means the tension is always away from the mass to which it is attached. Now let us come back to the problem. Here is a pulley, a fixed pulley. Here is another fixed pulley. And the mass of the pulleys are not considered. And the string, this string which passes over the two pulleys, also its mass is also not considered. And at this edge of a table, this pulley is fixed, and here this pulley is fixed, and there is no friction here also. Now let the mass of this object is m1. So the earth below it will try to pull it down with a force equal to m1 times g, its weight, which you can write it as w1. You may not write also. So in this part of the string, the tension for this object is away from the mass, let it be T, and it is the same string going over this pulley and this pulley, so all throughout the tension is same. If you consider this tension for the pulley, it will be to this side, and if you consider the same tension for this pulley, it will be away from it and away from it. And if you consider for this mass, it will be away from it. Similarly here it will be away from it. But we are not interested in the motion of the pulleys. So we will consider only the effect of tension on the two masses m1 and let it be m2. So if you write the equations of motions, the length of the string is fixed. From here to here is fixed. So if m1 is heavier, is sufficient enough to pull this m2 towards left, then this m1 will come down due to its weight m1g, and that is being opposed by the tension T. So T and m1g, they are opposite to each other, and it is coming to this side with, let's say, acceleration A. So the net force on m1 will be m1g minus T, will be m1g minus T is the net force on it. So that will be its mass times acceleration, make it equation 1. And if you come back here, this m2 is pulled to the towards left due to the same tension T. So T is equal to m2 times A, the second equation. Now this is how you can do it, and I will tell you the shortcut here. So if you add these two equations, the left added with left, minus T plus T cancels. On this side you are left with, taking A common, you have left with m1 plus m2. On this side is your m1 times g. So your A comes out to be m1 plus m2 comes to this side. So m1 over m1 plus m2 times g is your tension, acceleration. Now then, to find tension, if you put this value of A here in equation 2, because here there are three terms, here it will be faster to calculate. So here your T will be m2 times this A. So that is equal to, if you put this value of A here, this becomes m1 m2 over m1 plus m2 times g. This is how you do it. But to do it quickly, let me look at this figure. So what I have done is I have kept this M1 to do it quickly. I have kept this M1. This M1 is same thing as this M1. This M2 is same thing as this M2. So if you make this horizontal, this M1 horizontal like this, then this M1G is acting to this side. And in between M1 and M2 here the tension, which is an internal force, so I don't consider. And to this side there is no force towards the left of M2, as you can see it here. That is a force, tension, but that is an internal force, so I have not considered it. That is an internal force, so I have not considered it. So the net force is equal to M1 times G. Net force over total mass, M1 plus M2. So that is equal to acceleration, and this expression is the same thing as this. So this is how you do it faster in less than 1 minute. But there is no shortcut to find tension like I found it here. Why I have not taken T here, this T, because that is an internal force. This same T is here, internal, in between M1 and M2. So I have not considered it. So put this value of A either here or here, you get T as equal to M1 M2 over M1 plus M2 times G. You should rewrite it in a nice manner like this, M1 over M1 plus M2 times G. And if sometimes they might ask you to find the acceleration and tension in terms of weight, W1, means W1 is equal to M1G. So M1 is equal to W1 over G, right? Similarly here, they might ask you in a different manner, the weight of M2, W2 is equal to M2G. So M2 is equal to W2 over G. So you can substitute for M1, W1 over G, for M2, W2 over G, to rewrite these two equations, the expression for acceleration and tension, in terms of W1 and W2 also. So that is all about. I will upload few more videos for NEET 2021. In case you are asked a numerical and Pulley system, you can adopt these techniques faster, so it will be convenient for you. Thank you.